We want to solve quadratic equations using the quadratic formula, and we want to analyze the discriminant to determine the number and types of solutions. So the discriminant, we remember, is just the part that's underneath the radical. So we're just focusing right now on the b squared minus 4ac. So the first thing that we have to do is we have to identify all of the parts. So we have our equation written here. So we have x squared minus 6x plus 2 equals 0, and that's important. When we're using the quadratic formula, we have to have one side of the quadratic equation equal to 0. So in this case, we can, based off our equation, we have our a value is equal to 1, the b value is equal to -6, and the c value is equal to 2. And we just got those from the coefficients in front of the variables and then the constant term at the end. We're going to substitute those into the discriminant. So we're just going to substitute those into b squared minus 4ac. So b squared in this case, got to use our parentheses because we have the negative value. So -6, that quantity is squared, minus 4, and then the a value is 1, and the b value is 2. And all we're going to do is just multiply these and then subtract. So -6 squared is 36. And then we have -4 times 0, or excuse me, -4 times 1, which is -4, times 2, which is -8. And so this whole discriminant is just going to be equal to 28, which is positive. So if we're looking at the directions here, it says calculate the value of the discriminant and describe the number and types of roots. So we're just looking at this, and we have a value of 28. So we have 3 possible options here. Of our 3 possible options, we can have a value that is greater than 0. That would be positive. We could have one that's equal to 0. So this one we're just talking about 0. Or we could have one that is less than 0, and that one would be negative. So if we have negative, we have no solution, no real solution. If we have 0, we have 1 real solution. If we have positive, we have 2 real solutions. So right here we have a positive 28. So in this case, we're going to have a positive under the discriminant. So this will give us 2 real solutions.